Hi, everyone. My name is Michael Brennan. I'm here from Drexel University in Philadelphia, Pennsylvania. The title of this talk is Deceiving Authorship Detection, Tools to Write Anonymously and Current Trends in Adversarial Stylometry. Before I start, I just want to acknowledge the folks that work in our lab. We have a large lab back at Drexel. We do a lot of work in this area. A number of them are here with me, including our advisor, Dr. Rachel Greenstadt, Sadi Afros, who will be talking a little bit later, and Eileen Kaliskan, who's doing some work in this area as well. Unfortunately, the two lead developers for the two tools we'll be introducing a bit later weren't here, but they are available through email, and you can contact them. I'll put their emails up later when I'm demoing both of those projects. Before I get into the talk, can I ask, how many of you were here at my talk 2 years ago at 26C3? Okay, so some of you, but not most of you, which is good. So I'm going to have to go over some background on what stylometry and authorship recognition is, and it might not be as exciting to you folks in the beginning because you'll have heard some of this stuff before, but it's required to make the case for the rest of the talk. But I do want to highlight the fact that there is a bunch of new work even in this review that though you were there last time, I hope you get something new out of it, including a new data set, a new method that we're using, and more robust results in general. For everyone else, and all of you included, I'll give a quick overview of what we're going to be talking about. First, I'm going to introduce this concept of authorship recognition and adversarial stylometry. And then we're going to talk about the threat to anonymity that authorship recognition can present. We'll go over the experiments and the research that we've done analyzing deception concerning adversarial stylometry, or concerning stylometry in general. I'm going to introduce two tools that we've created that both help you do stylometry research and help you anonymize your writing style to deceive stylometry methods. And then Sadi Afros will come up and talk a little bit about detecting deception in stylometry. So the first basic question is, what is authorship recognition? Well, you want to know in authorship recognition who wrote some document of unknown authorship. Now, in this, there's a subset of authorship recognition called stylometry. Stylometry deals with determining authorship of a document, but purely through linguistic means. So we're not talking about handwriting, we're not talking about where the document was found or the historical context. We're just talking about linguistic features like the syntactic structure of the document, the word lengths, the words that were used, the sentence lengths and paragraphs lengths, the grammar, things that would generally be considered to be sort of like less context dependent. Now, the reason why this works is because individuals have unique writing styles, and they have unique writing styles because we all learn language on an individual basis. So we develop these nuances in our own style that are unique to us. And in this presentation, I sometimes use stylometry and authorship recognition interchangeably because authorship recognition, a lot of this stuff applies to authorship recognition in general, but keep in mind that stylometry is a specific subset of authorship recognition that deals with this linguistic aspect of the problem. So what is adversarial stylometry? Well, this is where we look at applying deception to writing style in order to circumvent methods of authorship detection. And we have to ask these questions. Was it possible to modify your writing style? Is it possible to deceive stylometry by doing so? And we'll see that the answer to both these questions is yes. And what are the implications of looking at stylometry in an adversarial context? So how can stylometry be a threat? Well, there's two basic problems in stylometry, the supervised one and the unsupervised one. I'll explain this briefly and give you a short hypothetical scenario for both of those. For one, in supervised stylometry is when you have a set of documents of known authorship and you have an unknown document, but you believe it to be one of the authors in that set of known documents. It's a supervised classification problem. And a hypothetical scenario here might be Alice, the anonymous blogger, versus Bob, the abusive employer. Alice is one of Bob's employees. Bob is an abusive employer. She wants to publicize these facts about the company publicly by posting a long blog post. Bob could potentially use stylometry to identify Alice because he has a set of known suspects in that context. He has his employees, he has writing samples from his employees, and he could, to a high degree of precision, probably identify Alice in that scenario. The second question is the unsupervised question, where when you're given a set of documents of unknown authorship, you want to cluster them into groups. So you don't know how many authors there are, you don't know how much writing there is per author, you just want to try and figure out what the layout is of the data that exists. And a hypothetical scenario here might be some sort of anonymous forum versus maybe an oppressive government, where you don't know how many participants there are on the forum, you don't know how many messages are attributed to each participant, but if an oppressive government could use a solid form of unsupervised telemetry, they could segment this into author groups and then maybe apply those author profiles to a supervised telemetry segment, maybe compared against members of parliament or something like that, to see if any members of the government are participating. Now, that's a bit of a scarier hypothetical. Unsupervised telemetry, though, there's a lot more research that needs to be done to make it more effective. Supervised telemetry, however, is very effective, and that's going to be the problem that we're concerned with in this talk. So are these scenarios purely hypothetical? Well, interestingly enough, a couple of members of WikiLeaks were at my talk here 2 years ago. And one of them wrote a book about his experience with WikiLeaks, and in it he mentions being at my talk. And they were talking about how at the time, essentially the organization was just the two of them. And they had all these fake personas for like their PR person and their lawyers and their volunteers. And they had to laugh because they thought, wow, if someone actually applied this research to our work, you might be able to determine that it's actually just two of us and not like hundreds of us. And I thought that was a pretty interesting scenario because it shows like a real world application for this work. It's also been stated publicly by organizations like the FBI that your writing style or people's writing style are being looked at actively as a means of identification. So this is something to consider, and I think it's something that's not in widespread use right now, but has the potential to be. So we should consider this as a concern from the perspective of anonymity and privacy. So let's review the research problem and how we analyze this, and then I'll get into the tools that we developed. So first we want to understand the threat model in adversarial telemetry. Then we want to build a data set, because we have to create our own data set, because an adversarial, which I'll explain in a minute, adversarial telemetry data set doesn't really exist in order to evaluate this data. And then we want to evaluate current methods of authorship recognition and telemetry against adversarial texts where people are trying to hide their identity, and analyze these results in order to develop tools. So what's the threat model? Well, the threat, like I said, is kind of obvious. Authorship recognition can identify you if there are sufficient writing samples and a set of suspects. If you have about 6,500 words or more per author, if you have 500 words of this unknown document, and you have 50 or less suspects, you can, with a very high degree of accuracy, identify the author of the unknown document. And this is not a strict threat model. There's plenty of research that looks at shorter messages. There's plenty of research that looks at authors on the order of 100 different authors, up to thousands of different authors, and still show very positive, very high accuracy in identifying authors. But for the purposes of this research, we're taking this kind of middle ground between the old telemetry problems where they just kind of look at 2 or 3 different authors, and these new ideas of looking at hundreds or thousands. And you can expand into those later. So this threat model is based on an old assumption, though, that writing style is invariant, that it's like your fingerprint and you can't modify it, you can't help it. Well, we think that maybe that's not true, so we came up with a few different circumvention methods. One is the obfuscation method, where an author attempts to write a document in a way that just hides their own writing style. The second is an imitation method, where an author attempts to write a document such to specifically imitate another author. In our examples here, we chose the author Cormac McCarthy for people to try and imitate. And then the third circumvention method is a translation method, where the idea is you take your writing sample, you translate it to another language using machine translation, and then you translate it back to yours. I'm not going to be talking about this, and I have an asterisk there because we actually found this method not to be very useful in anonymizing your writing. But we were doing some further research in different languages and in possible applications of machine translations. And Eileen, one of our colleagues, is here, so feel free to ask her any questions either at the end of this talk or afterwards if you have questions about that specifically. So we have to build a corpus. And when I say corpus, by the way, I mean a data set of documents. That's what corpus means, essentially. It's a data set of just text. And the reason we have to build this is because, yeah, there's plenty of writing samples all over the web, but we need writing samples of people to know their writing style, but then we also need attempts by them to actually hide their writing style, and that's harder to come by. So we ask people to submit 6,500 words of existing writing that's not modified. We ask them to write a 500-word obfuscation passage, where they try and just hide their writing style by any means necessary. We ask them to write a 500-word imitation passage, where they try to imitate the work of Cormac McCarthy. And Cormac McCarthy, by the way, has written a couple books like The Road and No Country for Old Men, so we picked an author just that people could kind of sink their teeth into and kind of get a feel for. And then, the authors here had no formal training or knowledge in linguistics or in stylometry. Now, we had our original corpus, which we presented 2 years ago, which looked at 12 different authors, and these participants that we got through the university, they were through friends. They had a motive there to participate properly and follow the directions because they cared about us, we hope. And we had one-on-one interaction with these participants. This corpus, which we used for our previous research, is publicly available at our website, and this website will be up multiple times throughout the talk. You can download it now if you want to do some of your own research on it. But it was good for preliminary results, but we needed something better, because this was too small and it was too homogeneous. So we went to Amazon Mechanical Turk to build a bigger data set. Now, for those of you who don't know, Amazon Mechanical Turk, as my advisor put it earlier, is like artificial intelligence. You source out a problem to a whole lot of humans for some amount of cost. So say you have a million photos that are of either dogs or cats, and you want to classify them and separate them. You could use some computer vision algorithms to do that, or you can farm out that problem to humans for maybe a quarter of a cent per photograph and get through them in a much faster way, and maybe even cheaper depending on how you're doing it. So we did this here. So the same task as the previous course, but as you might imagine, when you have that financial incentive, you also have the problem where people are trying to game the system and they just want to get paid and they're not actually honest participants in your study. So we had to come up with some rigid guidelines for what submissions we would accept, and out of the 101 submissions we got, we actually ended up accepting 45 of them. But we established these guidelines before we put that task out there because we wanted to make sure we didn't spoil our data set with our own bias. We determined what we thought would be the things we need to do this research, and we applied that strict set of guidelines to all the work that we got. So some of the guidelines are up there about, we ask it to be formal in nature. We want people to not submit a lot of dialogue and quotations. We want people to refrain from submitting small samples, in addition to the other requirements of having 6,500 words or more and having the sources be from multiple documents. So this is released today also, and this is what this work is based on. It's available on our website. This corpus is large, it's diverse, and it's unique. There are no other data sets like this in stylometry. So we hope that if some of you are interested in working with this stuff and doing some research, that you'll take this and run with it and share your results with us, because we would love to hear more about it as well. And then this is just a quick slide, we evaluated this new data set against the old data set and found really similar results. Some methods did a little bit worse, some methods did a little bit better, but we feel that this is a solid representation of writing samples, and that the conclusions we find follow the original preliminary conclusions on the original data set. So I just want to go over the couple of methods and go over our results here, and then I'll get to those tools. So we looked at 3 different methods of classification. The first method that we looked at was a basic set of 9 features. This is just 9 data points that we'd extract from text, including how many unique words there are, what the lexical density of the text is, a couple of readability indices. And we passed these 9 data points into a neural network classifier and classified the results. The results here, when you get to high numbers of authors, is not that strong, but it's still significantly above random chance. And the point of this method is to demonstrate that even a simple, very basic measurement of text can give you some pretty strong clues as to the identity of an author. The second approach is a synonym-based approach, where the only thing that is looked at are the word choices involved in the text. So say you choose to use the word verdant instead of the word green. Well, that might be highly indicative of authorship depending on how often the word verdant is used in the data set you're comparing it against. And this is interesting because it's really just a one feature point analysis of text, but it does a really good job of identifying authors. The final method that we looked at is right prints, which we consider to be kind of the gold standard of stylometry at this point. Now, the full-on right prints method is very detailed and has a method that has like a complex algorithm based on principal component analysis and has sliding windows and looking at the data and throws in a whole bunch of stuff. They also develop these really big feature sets. But what we did was took their baseline feature set, which is about 800 different data points from each piece of text, and just applied that feature set to a support vector machine, and we get accuracy that is at least fairly comparable to the right prints data. And we have some other research looking at right prints as a whole, but it can be kind of cumbersome to run. So when we're doing these experiments, we thought this was a good approximation of the right prints approach. And right prints does very well. In fact, in their paper, they claim that they can get up to 95% accuracy looking at 100 different authors in some data sets, which is pretty astounding. So we look at these 3 methods through 4 experiments. First, the baseline. We want to evaluate these methods and see how good they are just on your base text that's not modified. We want to look at the obfuscation passage and see how they do when someone tries to hide their writing style. We look at the imitation passage and say, well, how do they do when someone tries to imitate someone else? And then we want to look at the imitation success rate. What percentage of the people trying to imitate Cormac McCarthy actually tricked these methods into thinking that they were Cormac McCarthy? So this is the baseline data set. I'm just going to explain this graph a little bit. I know there's a lot here. On the x-axis on the bottom is the number of authors. So we have this data set of 45 authors, but we look at randomly selecting 5 authors, 10 authors, 15, all the way up to 40, because you see the accuracy degrade over time. The important thing, though, is not the degradation of the accuracy, but how much it degrades, or in some cases, how little. So the original 9 feature set, it starts off at about 65% accuracy with 5 authors, which again, is already pretty good compared to the baseline, compared to random chance of 20%. And though it decreases to about 25% accuracy, it's still well above random chance. But what's more interesting is that the synonym-based method and the right prints method sustain very high accuracies in determining your identity, even when faced with 40 unique authors. And right prints does the best in this case, only reducing from 95% to about 82% when you get to 40 unique authors. So that's interesting. So the takeaway from this slide is these methods are accurate, right? They do a really good job at figuring out who you are. So remember that assumption that like, oh, your writing style is invariant and you can't actually get around this because it's just ingrained in your subconscious. Well, let's look at what happens when we apply the obfuscation passages. They do really poorly. Right, so these methods that did really well, when people who are not experts in this at all just try and hide their writing style, they can do so with a high degree of accuracy. Now, there are differences between them, but they mostly get down to about the level of random chance. Even more interesting is when you get to imitation passages, accuracy drops to near 0.
Why are they worse than random chance?
I'm sorry?
Why are they much worse than random chance?
Why are they much worse than random chance? So our thought here about why they're worse than random chance and therefore do worse than the obfuscation passages is that when you give someone an imitation passage
They were worse than the previous one as well.
Yeah, when you give someone to mimic the authorship style of, they do an even better job, and it confuses the systems a lot into moving them towards other authors in the data set. And then when you look at the success rate in people actually successfully imitating Cormac McCarthy, you see that a lot of the times they're actually pretty successful in doing that. Even with 40 different authors, when you look at the synonym-based approach, almost half of them are successfully tricking the method into thinking that they are Cormac McCarthy. But there's another important and new result here, which is that the right prints method, while it's susceptible to these passages, is not as susceptible. It's maybe only about half as susceptible as the other ones. So our hypothesis for a while has been that some methods will be more resistant to these obfuscation and imitation passages than others, and this is the first really obvious example that we've seen of that. And that's important because stylometry is a developing field, and we don't want to give anyone the impression that if you can circumvent these methods that you are necessarily going to be anonymous. You can't really measure in that way. It's possible that other methods down the line will study your authorship and your writing style in different ways and still be able to identify you. So that's a recap of the work, some of it which I talked about 2 years ago, but that I hope you see is a lot more robust now for those of you who were here last time. And now I want to talk about 2 tools that we've developed. One is called JStylo, which is an authorship recognition analysis tool to help researchers like us do this work. And the other is Anonymouth, which is an authorship recognition evasion tool. These are both free and open source. They are under the GNU GPL. The alpha releases for these are available today at this website. Feel free to go download them now if you want to, download them later, come talk to us. And right now, they're just tarballs with the source code and the jar files in them, but we'll be migrating them over to GitHub soon, so more folks can be actively participating in the development as it goes on, rather than just waiting for us to release tarballs every now and then with the source code in it. And I want to stress again that these are alpha releases. These are our first releases, so there are issues with them. There are some bugs and things like that. We welcome all input, whether it be a bug report or a feature suggestion or, hey, this is how I'd like to use this software, and I can't do it that way right now. Please, submit that to us. So developing JStylo, I want to outline the problem that we're trying to address by developing it. The main problem is that stylometry-based research is difficult. We think that this research is important, but existing tools are limited. You have things like Weka, which is a suite of machine learning classification tools. But these are not tailored for text analysis. There's no built-in feature extractors. You have to write your own code that's going to extract these features and then feed those feature vectors into Weka. It can be a cumbersome process. It takes a computer scientist or a programmer to learn about this stuff and then implement it. And then we have the Java Graphical Authorship Attribution Program, which has a strong basic toolset for stylometry, but is limited in some of its features. Though, again, this has a strong API, and it's meant to be extended and built upon, and that's what we did here. So the nuances of stylometry are not easy to grasp, and there are many open research questions related to authorship. The most common questions I get asked, and it will probably happen here today too, is after I'm done talking, I get all these questions that are like, have you looked at authorship recognition in this domain? Have you looked at it in this domain? What about these documents? What about this book? And we don't have enough, there's so many questions that could be answered that would be interesting, and we don't have the resources to do it. And we often say, yeah, if you want to get started, just do it and let us know what you find out. But that's really difficult because there's a steep learning curve to get involved in this research sometimes. So hopefully we can reduce that learning curve and encourage more research and analysis in this area so that other folks can be interested in it as well. So JStylo is built upon a framework of JGAP and Weka. It has the two existing adversarial corpora that are releasing here. And there's a new corpus building functionality, so you can quickly put together and easily put together a bunch of documents and save it and hold on to it so you can analyze those over and over again. There's a wide selection of feature extractors and the ability to add new extractors. I mean, right now, if you want to add them, you have to, write a function to do it and then recompile the code, but you can do it. But you can actually configure new features based on existing extractors right from the GUI. There's a wide selection of machine learning-based classifiers, mostly coming from Weka. And there is what we think is an intuitive GUI that walks you through the process of this research, step by step, which hopefully is helpful. And again, the alpha release is available now. So I'm going to give a quick walkthrough of it. I hope you don't mind that I made slides and didn't do a live demo. I'd rather talk and point at things than like type and click around a lot. So bear with me on that. So the first screen you get to is just where you can load in your test documents and your training corpus. So your test documents are the things you want to analyze. And your training corpus is the data that you are going to be comparing against, your set of suspects in this supervised stylometry problem. You can then go on and start working with different sets of features. So we have 3 built-in feature sets that we've been working with, but you can add your own and configure your own and make your own. You can look at and understand each of the individual features. Like here I have complexity highlighted, and you can see, not just name and description, but what the pre-processing steps are. So complexity, for example, is the ratio of unique words in a document to the total number of words in the document. And some pre-processing steps we want to take are to strip the punctuation out of it, unify the case across the whole document before we extract this feature. So again, this is useful because these are all steps that there's no easy way to put them all together. There's all this disparate code, and people said, hey, can we do some of this work? Can you send us some of your code? We'd be like, yeah, sure. And send them a bunch of Python scripts that were a bunch of research code, read, not easy to understand. And it was difficult for people to do that work. Then we have the classification step where you pick a classifier. You can understand the details of that classifier. Again, soon we'll be adding support for multiple classifiers at the same time, and then you analyze it. And essentially when you analyze it, you're going to be doing one of 2 things. Either you're going to be analyzing these test documents that you put in there to see how good your method does against it, or you're going to be building a new method that you want to analyze and validate on itself. So in the first case, when you're doing the test documents, I put in a bunch of obfuscation passages, and if you zoom in on the text, you can see which each document was classified as. All these were mostly classified as author BB, and one of them was classified as author C. And then when you're doing the overall, validating a method of stylometry, you can run that through and get an overall accuracy on basically metrics on how good that classifier that you just built is and how effective it is against some data set. So we have some development goals for JStylo going forward. I mean, that was just a quick walkthrough of it. We want a wider selection of classification methods and features, including right prints, the synonym-based method, which are not built into this yet. This is not the tool that we've used this tool in part to do our existing research, but the graphs I showed you earlier were still created from this hodgepodge of different methods that we're using, and we're hoping to unify that in one tool. We want to add ensemble classifiers with weighted averaging. We want it to be easier to understand for non-technical users. So we want people to be able to plug in different feature extractors that other people built and share those. And we want some better visualizations and logging and graphing of results over multiple experiments, such as visualizing the documents, the authors, and the classifications. So moving on to Anonymouth. Anonymouth is our deception tool. And the problem here is that authorship recognition can be a legitimate threat to privacy and anonymity. Our intuition in changing our writing style goes a long way, but it may not be enough and may not be sustainable over a long period of time. Some methods are better than others in still determining who you are, and you might need assistance in knowing what you need to change, what the most identifying aspects of your writing style are, and what needs to be done about that. Fully automated text anonymization is an intractable problem. You can't make a piece of software that you click a button and it maintains the meaning and the content of your writing completely and still anonymizes it. If you can, let us know. There's probably some awards out there for that or something. So we need a solution that explains authorship recognition, the nuances of it as they're needed to an individual and helps assist them in making the most useful changes towards anonymity. We're talking about a system where the artificial intelligence that's involved in the classification problem acts to augment your own intelligence. It's not meant to replace your intelligence and do it for you, but to help you focus your own intelligence and how to modify your document and how to change it. So Anonymouth is built on top of JStylo. I mean, the main reason JStylo came out is that we can't have Anonymouth without JStylo. So we need to build the analysis tool and then build a deception tool around that analysis tool that can look at the deception aspect of it. And Princeton's WordNet, which is a large lexical database. It has the same corpus, feature extractor, classifier functionality of JStylo. That's all really good. But the main selling point, if you will, of Anonymouth is a suggestion system for modifying documents to evade authorship detection. The ideal value for each feature, each data point in a document is calculated and presented to you. It's calculated through a modified k-means clustering algorithm where it finds basically the different clusters in which authors exist around for certain features. Like, most people, a bunch of people have an average of about 20 sentences per document, and a bunch of others have an average of about 12. But you probably want to go towards the 20 because that's the ideal point for you to be anonymous in this set of authors that you've given us. And if it's possible, we highlight the existence of these features and explain to the user how to change that feature to help anonymize their document. And it takes an iterative approach to anonymizing writing style at the moment, where you make the changes you need, you reprocess it, it then tells you what the other features are that still identify you. You make those changes and you reprocess it and move forward with that. And once again, the alpha release is available now on our website, psal.cs.drexel.edu. So I'm going to walk through Anonymouth. Now, notice that Anonymouth actually is very similar to JStylo, except the first and the last panel, which are kind of like the guts of Anonymouth. So the first panel, in this case, you have your document that you want to anonymize. You have your sample documents that establish your writing profile, because it needs to know what your writing profile is compared to the set of authors that you are trying to mix in against. And then you have that set of authors that you're trying to mix in against and be anonymous among. And you can preview the document and stuff like that. And you can also create problem sets and incorporate in here just like you can in JStylo. So that's useful. Again, the feature selection and the classification screens are basically the same because you're setting up the methods by which you want to analyze your document. But then you get to the editor and the processing step. So in this case, you edit your document. You bring your document in, you process it, and in this example, it's showing that the red indicates that it still thinks that you are you. It thinks this document is attributed to you. And on the right here, On the right here, we have this set of features. In this case, again, for simplicity's sake, we just picked that 9 feature set so for the purpose of the demo, but you can have much longer and more complex sets of features. And we, as a next step, start walking through those features. Now, you click on the first one, you'll see it says, hey, actually, your first one, complexity, it's actually in a good spot. You don't want to change that. That's actually not the thing that gives you away. And as you go down the list, you find that also the character space and the unique word counts, those things don't give you away. But you know what gives you away is your sentence count. See, you have 19 sentences in this document, and really you want to have it more like 28. So I went through and I took this document and I just did something simple. Again, this is a really simple example. Don't think this will anonymize your document just by like throwing a bunch of periods in it. But in this case, I threw a bunch of periods in it and brought that target value, brought it up to about, I think about 28, and then reclassified it, and now it thinks that I am another author. So again, a really straightforward example. But features can be more complex. For example, if we were looking at the average syllables in a word, in this case, it's saying, you know, maybe take it as a compliment, right? Like you're using really complex words. There are 1.8 syllables on average in your document. You really want to get it down to more like 1.6. So here are all the words in your document that have too many syllables that we think you can easily change. So why don't you go through and try and modify some of those and bring that value down so that you can modify your document. And there's much more to this. There's more complex feature sets. There's better highlighting methods. But again, I just wanted to take you through a simple example to walk you through kind of like what Anonymouth is intended to do. So there are some real interesting research questions and challenges in developing Anonymouth. The main one is that features are often not independent. So if you increase the number of complex words, you will also increase the average syllable count of your document. If you reduce the number of times a specific word occurs, you're also going to increase affect the lexical density. So all these features interplay against each other in this process. And how can we create an algorithm for anonymity for anonymizing a text document that generates an obfuscated document with minimal effort and without circular feature modification? This is, I mean, we think our software does a pretty good job right now, but this is still an open problem and something that we need to tackle. And that's one of our main research focuses going forward is addressing this problem. And we have some development goals for Anonymouth just like JStylo. So we want to streamline the suggestion system. We want to improve the automation on certain features where they can be more easily automated. Improve the clustering algorithm so you can more easily see the path to anonymity that you need to take in terms of what features you need to modify when and in what order. We want an improved editing interface with better phrase and word synonym support that allows you also to edit by blocks of text, not simply feature by feature, because maybe it says, you know, you need a bunch more sentences and you break up the last paragraph, but that leaves the rest of the paragraphs untouched. So those paragraphs might still have your identity stamped all over them. So we need to analyze it maybe at more micro levels. And we want to look at wider sets of features and classification methods. This is tied back into the JStylo development goals. And we need to do some usability and anonymity user studies. So there's a long way to go, but we think that this tool is a good first step towards allowing people to take some steps to anonymize themselves in text documents, because currently there's no method out there other than just your intuition in order to do that. So, and your intuition will get a lot better if you study stylometry, and we don't want to subject you to like having to come sit in our lab for a few months just to be able to anonymize a document. Hopefully you can just download this tool and do some work on your own. So again, I don't want to promise that I make no promises that using this tool right now is going to anonymize your document. This is meant to be played with and toyed with and see where it's good and where it fails, and let us know, and let's work to improve this. And if anyone wants to join in that process, please get in touch with us. So we're going to continue to develop this at our lab, but it's open, it's free, and we are always interested in linguistic experts, security advisors, and user interface experts to help us make this better. So if anyone's interested, again, feel free to contact us. I'm going to turn it over to Sadia Afroz now, who is going to talk a little bit about detecting deception in stylometry, and then I'll come back up and recap.
Hi. Thanks, Mike. I'm Sadia. I'm going to talk about stylistic deception detection. As you have seen in the previous slide, that when people change their writing style, it's very hard to detect exact authorship. So we here try to solve a more general and simplistic problem. That is, given a bunch of document, can we distinguish regular document from the obfuscated and imitated document? And we found that with a large enough linguistic feature set, we can distinguish regular document from imitated and obfuscated document. We used three different feature sets. The one that worked the best is the right-brain feature set, which is a really broad set of linguistic, content-specific, and non-content-specific features. And we have about 85% accuracy in detecting imitation document and 89% accuracy in detecting obfuscation document. The second feature set we used is the line detection feature set, which contains 16 linguistic features that were found to be useful in detecting lying in a written document. The reason we wanted to use this line detection feature set is that when people lie, they generally use simpler languages and shorter sentences. It might not be true for people who are very good liars, but it works for most people. And so people change their language when they're lying, though that change is involuntary. And in our case, we are asking people to change their language voluntarily. So we wanted to see if people change the same kind of languages when they're lying. And we found that the line detection feature is much smaller than the right-brain features, but even those features are very salient in writing style change detection. And we saw that it can detect imitation with 75% accuracy and obfuscation with 60% accuracy. We also used the 9 feature set that are generally used for authorship recognition, and we saw that it does not work very well in distinguishing regular documents and deceptive documents. So we looked into the documents to see what people actually do when they're trying to change their writing style. This graph shows some of the major features that were changed mostly, and we found that in an obfuscation passage, people used more existential there, more adverbs, and they used simpler languages. That's why the readability index decreased. In imitation passage, we noticed a decrease in readability index, and people use less adjectives and adverbs, but more particles and personal pronouns. One problem with our data set is topic similarity. All the deceptive documents were of same topic. When we asked people to obfuscate their writing style, they wrote about their neighborhood. And in the imitation data set, they wrote about their morning, and they imitated exactly one author. So topic similarity might be a reason why we can distinguish this different kind of writing style. Though we used non-content specific features to see if topic similarity is a reason, and we found that non-content specific features gives us almost same accuracy as content specific features. To see that content similarity is not at all an issue, we used a different data set, which is the Hemingway and Faulkner imitation corpus. We collected 36 winning articles from the Hemingway and Faulkner imitation contest. And in this contest, participants were asked to imitate Hemingway and Faulkner to write a 500-word document about anything they want. So all these documents are written by 36 different people, and they imitated Hemingway and Faulkner in different ways, and they used various number of topics. So topic similarity was not an issue here. And even in this case, our method works more than 80% case, and we can detect regular Hemingway and Faulkner document from the imitated Faulkner documents. In both of the data set that I discussed now, people change their writing style just once. So, and in our data set, they used on average 30 minutes to an hour to change their writing style. So we wanted to see how our method does if someone develop a new writing style over a longer period of time and uses his new style over and over. In that case, the simplistic linguistic changes that are evident in our data set might not be evident in long-term deception because he had enough time to modify and edit his writing style, and he became more fluent in that. To see how our method works in long-term deception, we collected blog posts from a gay girl in Damascus. This blog was originally written by a 40-year-old American male, Thomas McMaster, and he pretended to be a Syrian gay woman, Amina Araf, and he wrote about Syrian political and social issues. And he was so convincing in his blog post that journalists from CNN and New York Times started quoting him during Syrian uprising. So we took this blog post. So this author, he opened this blog in 2010, but even before that, he was writing as Amina in Yahoo groups from 2006. So he had a long time to develop a new writing style. So our deception detection method did not work in this case because, as I said before, he had enough time to develop a new style, and the simple linguistic features that we used were not evident in this case. But when you're maintaining two different writing styles, more than one different writing style, it's hard to be consistent. So in these cases, regular authorship recognition can help to detect that there is something wrong with the writing style. And when we applied regular authorship recognition, we found that more than half of the blog posts were attributed to Thomas. So this is one example that why we need a tool like Anonymouth, so that you can change your writing style more easily and be consistent with it. Thank you.
So just a quick recap of our work. What's available now is our original stylometry corpus, which has 12 authors, our new adversarial stylometry corpus, which has 45 authors, and the alpha releases of both JStylo and Anonymouth. What you can look forward to if you're interested in coming out of our lab are beta releases of JStylo and Anonymouth that include some of these development goals we were talking about, academic publications of our new results, because we're in academia after all, and we need to do that, and continued analysis of deception detection and short message classification, and continued research on improving this partially automated anonymization method or suggestion system and tool that we've been talking about. We think there's a lot of interesting research problems there that we hope to work on. So here's all of our contact information, including our website. One last thing before I take questions I want to say is that we are looking for interested grad students and postdocs. So if you're interested in this area, if you're looking into starting a graduate degree or looking for a postdoc, please come talk to us or send us an email, because we are looking for folks to work on this with us. So with that, if anyone has any questions, we'd be happy to. I think we have, 10 minutes for questions maybe?
So first of all, it's online? Yeah. Thank you for your talk, both of you. Now we have, I would say, really 10 minutes for questions. We have an audio engine going around and a signal engine in the IRC. But first, before we start with the questions, don't forget to give your feedback in the Pentabarf again. Don't forget to take out your trash, especially the 3 Mate bottles who fall down some minutes ago. And yeah, let's start with the questions, please. Can you hold up your hand? Can I see anything here?
Thanks.
Okay.
Not knowing anything about linguistics, I have 2 questions. Is it Unicode compliant, your tools, and what language does it work with?
First of all, where are you? I don't know where I'm. Okay, and can you repeat that question? I'm sorry.
Sure. Is it Unicode compliant? I mean, your tools, and what languages do they work with?
They're written in Java, and I didn't hear the first question.
What human?
Oh, Unicode compliant. Yes, they are Unicode compliant.
Mm-hmm.
Okay,
yes.
and like English, Swedish, whatever, those kind of languages.
Yeah. So we haven't. So there's a lot of work to be done, which our colleague Alina is working on regarding how different languages respond to authorship recognition. Most of our research has been done in English languages so far, but these tools do support Unicode, so Unicode encoded text should run through these tools just fine. So you can, if you want, try some other languages and let us know how it works out.
Just a short interruption. For the people in the back who ask a question, could you please stand up? The light here at the moment is in such a way that we really can't see you at the moment. So the next one, please. Okay, I'll take one from the front.
Okay, I'm thinking about the reverse use case for this stuff. So let's say somebody's writing Harry Potter fanfiction and they want to match the style of the original Harry Potter. It seems like they could use these tools to just more or less have the fanfiction be more like Harry Potter in style. Of course, not in content. The content is completely ridiculous. But just to match the style better, does it sound like a reasonable use case?
Yeah, it does sound like a
Like it
reasonable use
work.
case. That kind of functionality is not quite built into our tool, that you could certainly spend some extra time and get around it. So our tool, when you put a document in there, it's going to try and give you enough information to anonymize it. But you could keep running it through until it shifts towards the author that you want, even though the suggestions aren't telling you to go towards that author. But yeah, certainly I think that if you are building an anonymization tool like this, I'd be interested if anyone has any ideas of how to build it where that use case would not be possible, but yeah, that is possible.
Yeah, I may be asking a stupid question because I missed the first couple of minutes of your talk, but this was a pretty technical talk, and when I think of the topic, I have many political and cultural questions in my mind. For example, I'm thinking of mandatory in America, when you study or go to, I don't know if it's done in high school too, if you study in America, odds are that you have to submit your papers to a firm that collects a huge database of writing styles, actually. And what are your thoughts about the political implications of your work, or are you a little bit timid to take a position on that?
I think that there are implications for this work in all areas, both positive and negative. I think what you're talking about is the idea of plagiarism detection, which is really common in universities and colleges. We haven't done any direct work to see how this will affect plagiarism detection, nor have we done work on really like how much time it would take you to anonymize a 10,000-word document as opposed to just write it yourself in the first place. So, so I think there are a lot of implications for that, but I don't want to make assertions without data to back it up, and I have not done research in that exact area. I do think, again, that hopefully these tools will allow people to ask and answer questions like that. That's part of the point of us releasing these tools here.
What level of guidance did you give to the mechanical Turkers for the obfuscation task? Because presumably the language you use there will affect the techniques they use in obfuscation.
Yes, so for the Mechanical Turk task, in Amazon Mechanical Turk, you can actually request that request certain Turkers. So that's what they're called, Turkers. So we requested Turkers that were from the United States and whose
native language is English.
Yeah, whose native language is English. Yeah, I guess you should probably address that more if you have any more to say about that.
We just said it's the same way we did we collected our original sample. We just asked them, write in a way that you don't usually write. And we didn't give any specific direction.
You didn't guide them towards specific techniques?
No, we didn't guide them towards specific direction. But after we had the data, we saw that most people changed the same thing. That everybody used shorter sentences and simpler language, simpler words. But we didn't guide them anything anyway.
Going back to the example of the American block writer, could you also detect whether somebody is writing in their native language?
We are working on that native language detection. That Eileen might.
Yeah, our colleague Eileen maybe can answer that because she's working on.
Please use the microphone.
The
Yeah,
microphone
can you
here.
Could you repeat the question again?
Native language
They want to know.
detection.
They want to know if you can identify the native language of authors.
Yes, you can definitely identify the native language of authors, and you can do more things on it, like identifying their language family if you're not able to identify the native language. So this is another research area.
So I'm going to take the question from the IRC now.
One of the questions from IRC is, if everybody uses the same anonymization software to anonymize their documents, what is the result?
That is a good question. Again, I mean, in short, I know you've had, like, we don't really know. The hypotheses that we've thrown around are, do people move towards some sort of like standard tongue for that people can talk in this more anonymous way, or some sort of simple English? But I'm not really sure. I think that the best answer I can give is that it's going to be context dependent. One major point in stylometry that's accepted in stylometry research in general is that there is no one-size-fits-all solution. If you want to study a specific area of stylometry and identify an author, you need to look at the clues and the context of the domain that you're looking at. And my, again, hypothesis, we don't have enough data to back this up, my hypothesis is that you will have the same sort of constraints when you're trying to anonymize your document. So the means of anonymization and what you do to change your document will depend on the domain in which you're changing it. So the steps you take to anonymize a scientific research paper as opposed to a personal political blog may be different. But we'd like to research that and come up with some actual hard numbers to explain that.
And also, we ask people to set their own corpus towards which they want to go. So if different people choose different corpus, then even if they're using the same tool, they'll be leading towards different averages for features.
And the second question is, what happens if I write a text, are spelling mistakes are also considered for comparison? Maybe anyone could remember, like, E and H, like...
Yeah, spelling mistake was one of our features.
Those are specifically included in the right prints data set, or spelling mistakes.
Okay, and then one more. What happens if I write a text together with others? Will it be more complicated to identify a text where more than one author was involved in one text?
There is some research looking at, I think the question was, is it harder to identify the text if there's multiple authors, or can you even identify what authors wrote what parts of the document? There is existing research on that shows that you can identify when there's multiple authors in a document. I think that there's more research to be done in how to obfuscate that, or maybe even how to obfuscate the fact that there were multiple authors there in the first place, and if that's even possible.
Do you have free and open lists with distinct linguistic features of text that you suggest are creating the individualistic style, so that we can look up at those lists and find out what are the distinct features?
So these lists are in some of the papers we published, but actually the easiest way to look at the kinds of features that we've used is download these tools, and you can look at the existing feature sets and just go right through the list, and it explains, most of the features have descriptors, they say what steps are taken to pre and post process those steps, those features, all sorts of stuff. So I recommend downloading, in that case I would recommend downloading JStylo and just taking a look at the different features so you can kind of get an idea of what things are used there.
Do you know if there's any corpus of linguistic samples that are sorted by partially de-identified sociological data? So if someone's trying to move their fingerprint and the deception fingerprint shifts over time, but the identification fingerprint goes back and forth, so is there any corpus of data that's actually like someone of a lower socioeconomic class, native speaker, female, region, or anything like that compiled in a database so people can look at the fingerprint styles?
Well, other than our corpus, no. We do have demographic information associated with the samples that we've accepted. Oh, and maybe Eileen has something else to add, but we do have demographic questions like, what is your education background, how old are you, what's your native language, and things like that associated. Again, people volunteer this stuff, but...
Okay, I know that there are data sets that are collected in this way. The Linguistic Data Consortium at Penn has some of them, but you have to buy them generally. They collect different demographics and things like that, and so we didn't want to, we couldn't include them in these sorts of things. Plus, for example, Eileen is working on, you can say.
So in Belgium, there's the ICLE data. And this is International Corpus for Learner English. So these are people that are studying English all around Europe from 16 different countries. And their native languages, and they have upper intermediate English. So this is what we use to look at their native languages. And there's the L1 to L2 transfer fact. L1 is your native language, and L2 is the language you learn later, which is English. And from these, we can identify the native speakers. So that's still a fingerprint.
I have a question.
Yeah, go ahead.
About the Hemingway detection example, did you tweak your algorithm to detect Hemingway? And if you did, how did you avoid overfitting because Hemingway is dead and you can't get any more cross-validation examples out of him?
No, in our training sample contained Hemingway, Faulkner, and Cormac McCarthy, and a bunch of other authors too. We didn't tweak and overfitted our algorithm anyway to detect Hemingway.
He's been reaching really hard the whole time. Okay.
I'm curious as to how well, or if at all, the stylometry features or methods that you presented here work to get indication of an individual's non-authorship of a text, thinking ghostwriting.
So this is one of the situations where we think that's an open research question that we don't have data to support looking at ghostwriters and how they can be attributed back to the true writer, but one that I think is worthwhile, and I think we all would agree is worthwhile, that hopefully people can use these tools to do some of that analysis on.
So getting back to this question of fanfic, could you imagine, for example, that Harry Potter fan authors, a big vibrant community, might over time tweak an anonymous-style tool so that anyone could Harry Potterize any arbitrary block of text, and that might become a great a positive externality, you know, the reverse of what Jacob was talking about last night. Suddenly we've got this awesome tool, anyone can make any piece of prose non-fingerprinted, or rather fingerprinted to Rowling. Yeah. And this, by the same token, could you frame someone by using Anonymouth to make terrorist rants sound like their prose style?
So for the first part, yeah, I think that is a potential logical extension of this work, and I think an interesting one, exciting one. As of the second part about framing, what I would personally hope that people take away from this is that writing style and stylometry has been used in court. It's not used so much recently, but there were some older methods that they ended up realizing weren't that good that had been used in court. And I hope that before people get the bright idea of using some of these newer methods in court, they realize, hey, wait a second, you kind of can't trust writing style as a true means of identity if there's the potential for deception to be there. So I would hope that that wouldn't be the case, because I'd hope that people would realize that.
Hi. You, in the beginning, told about the possibility to translate something and translate it back, maybe with different tools or into different languages, but you didn't show any statistics or didn't mention it at all afterwards. Did that completely fail, or why didn't you mention it?
So again, it was something that I actually had slides for in the last talk I gave a couple years ago, and I probably should have thrown some addendum slides so I can slide to them here now, but I don't have them. If you actually go back and look at the talk from 2 years ago, which I believe the slides are up on the site, you can see some graphs that we show where the obfuscation attacks and the baseline accuracies don't change. The overall accuracy does not change much. I think you get basically like if it's 65% accurate in determining your authorship, and then you run it through a translation system and back, you get maybe 50 or 55% accurate. So it does reduce a little bit in some cases. In other cases, it didn't reduce at all. So yeah, I apologize for not having the data here. There's a lot of stuff I wanted to cover, but that is in the last talk, so feel free to go check it out.
So we'll take one last question. Anywhere? I've seen one. Wonderful.
All right, some practical advice then. If you're with a activist organization and you need really fast to type up a press release or a comment to something, and especially if you're not a native English speaker, what's your advice? What kind of mindset? If you have to do this in 20 minutes, how do you think?
Pick an author with a distinct writing style and try and imitate that author. I think that's the best way. So the one thing I want to add is these samples that we did, people spent between a half hour and an hour writing these, doing the whole process. So I guess you could probably say they probably spent about 20 minutes in each of these 500-word samples. So that's a lot of time for maybe 500 words, depending on what you're trying to do. But I think that's the clearest way to anonymization at this point. And I'm not saying it's going to make you anonymous, but at least the closest to it is to pick an author with a distinct writing style and try and imitate that author.
Did you test that also for non-native?
No, we have not tested it for non-native English speakers. And we'd be interested to hear what happens if you do.
So wonderful. Thank you for these many questions.